Hi, my name is ABHIJIT and I run some of the emerging products in Veritas software. We are going to talk about a feature that we have done in OpenStack for Manila and Cinder, a multi-tenant storage solution. With me, I have Sachin. Sachin runs the product of which this feature is a part of, and we both work in storage engineering within Veritas. So multi-tenancy for Manila and Cinder. So let's look at the real issue of multi-tenancy. OpenStack is inherently built for multi-tenancy, right? But the problem is the storage backend is not supporting complete tenant isolation. Why would you need tenant isolation? Now, tenants are applications which access their storage, run their whatever they need to run. They need complete isolations in today's enterprise, right? So if you don't have the storage backend also supporting multi-tenancy, you don't really have complete tenant isolation, which has security issues, compliance issues. You could have the fault propagated from one tenant to another. Ultimately, they are sharing systems, so they should be completely end-to-end isolated. That is multi-tenancy, which full secure isolation, right? So our solution here is extremely simple. There are a lot of solutions you could do to make tenant-level isolations. Some companies uses directories level isolation. Some will use a virtual machine for isolating. Even the virtual machine is pretty heavyweight for tenant isolation in OpenStack environments. We chose to use containers, Linux containers, for providing a lightweight, efficient solution for achieving end-to-end tenant isolation. Right, and we'll talk about it. So let's really understand what's going on here. So on your left, you have two applications: a finance application and an HR application, trying to access a Manila share in OpenStack, right? So Manila, as you know, is a file storage provider. It's a file-based provider. Like Cinder is a block-based provider in OpenStack. So these two applications are running. They're accessing a Manila share, which is protocol presented by backed up with NFS services, which could be coming up from any storage provider. Veritas is a storage provider. It could be exported by any other storage provider, right? And then you got the storage subsystem, the volume manager, the file system, and your LUNs. That's really this configuration on your left. Now, even though on the top you see the tenants are isolated, which is OpenStack's premise, on the back end they are not. They are hinged because the storage is not isolated. The back end is not isolated, right? So that's the challenge, right? If you look at the picture on your right, you will see it's kind of one step ahead. So now you got two sets of LUNs, two storage subsystems connected to an NFS service provider, a storage provider, which is exporting NFS shares over Manila into these applications. But it's still not cutting it because you are still not really end-to-end multi-tenant or isolated, right? We said that we need to have from guest to spindle level tenant isolation. So that's why we are calling it this kind of solutions partial multi-tenancy, right? So in Veritas, again, this is a separate product we have been working on, and we are going to talk about it in a few minutes. But as part of that product, we are providing a persistent block-based backend through Cinder for OpenStack and a file-based blockend through Manila. And what we are doing for Manila here is, let's say the storage service request comes in from OpenStack through Horizon. We spawn a Linux container, which then links up to Manila over NFS, presents it to the Nova virtual machine. That's how it provides the file-based storage, right? Now, if another request comes in, we will spawn another Linux container, and now you see that we can provide a clean, separate isolation between tenants through containers, right? That's really what it is. I'll let Sachin walk you through a deeper demo of this, and
yeah.
thanks.
Thanks, Abhijit. So as Abhijit introduced the problem that we're talking about here, it's really providing a storage multi-tenancy for OpenStack. So this is one of the solutions we chose. We chose the lightweight containers as the approach to bring out this multi-tenant attribute into the storage backend. What I'm going to show here is a second level deeper visualization of what Abhijit just went through, which is a container-based storage response back to the compute, and a little demo which shows things in action, right? So that's what the next few slides are going to go over. I will stop in between and and go over to slow things down to explain. All right. Okay, so I'll let the next slide show up. All right, so this is kind of a sneaky, funky way of showing what we talked about earlier. Things in action. Here you're talking about a private cloud which has really the multi-tenants. You look at a finance and a billing department with a real production media serving app group that are being hosted on the OpenStack private cloud, and we need, we really need to have them get isolated storage. You really do not want a finance data to be sitting on a media server storage backend. So essentially what this comes down to is having a storage backend which is able to honor this request from the compute. So you're looking at a workflow where a finance and billing app comes up on OpenStack and asks the Manila driver, hey, give me isolated storage. So through the driver that we are proposing inside of Manila, what would happen is as soon as we get a request from the compute to access the share, we spawn off a container. We host the NFS services inside the container, and that NFS service exports the storage which is created on a dedicated storage pool. So, and similarly, when a second request comes in from a media server app compute node, we would spawn off another container, as Abhijit mentioned in the previous slide, and we will attach it to the, to the Manila driver that we have. So this way, if you see, the two sets of groups are getting isolated storage. They have service level isolation as well. As you know, inside of containers, all processes have their own space, and there is service level isolation that we achieve. If one service goes down, your other tenant is not impacted. So that's really what we are going and trying to put out there as a solution. This so happens to be built on the storage backend that Veritas has, but as a technology, it's something that we feel will really fill one of the gaps in OpenStack. So let's see, I want to move forward. Yeah, so this is once we are providing the access, we go into the data path. So the next is really a demo of how things happen on a real backend system. This is a demo that we have recorded on a storage backend that Veritas has. Really, what we are doing here is we are trying to add the storage backend into OpenStack. Through Horizon, we're going to manage it. We're going to provide the Cinder and Manila personality to the backend inside of Horizon and try to access those shares and volumes from the compute. For sake of simplicity, we have chosen Manila as the example that we'll go through. The first set is really going to show the configuration that one needs to do to enable the backend inside of our OpenStack. It's a very simple set of configuration steps that we will add into Manila.conf and Cinder.conf. Once you do that, your storage backend is available inside of Horizon and for you to be able to provision your shares. So what we're going to go through is, again, a multi-tenant environment and trying to satisfy requests. So we get a request from a compute or a storage admin to create an isolated share for an HR team. So this is inside of Horizon, where we go through and try to create a share. What's happening at this stage is OpenStack is talking to the backend and it's trying to get the share created. After that, you're really trying to attach this share to the compute. And what you will see here, this is on the storage backend, what you see highlighted in yellow is the container gets spawned off and your NFS service is running there. There are no NFS services running on the host, which relieves the host from the CPU cycles and the burdens of not having to do that. Similarly, when we go into the finance share, we are going to get a new container that gets spawned off and is completely isolated from the first container that got created. So this is our hypothesis that with this, we will be able to provide a storage level multi-tenant backend for the multi-tenant OpenStack. So in summary, right, so you looked at the previous slide which articulated the problems with multi-tenancy. This is our hypothesis. We feel that with the containers, we have a really lightweight mechanism of separating the services sitting on dedicated storage backend and being able to provide the requests from OpenStack. So with this, we have achieved the storage level isolation security. We are also able to guarantee some level of security, and we get the storage backend multi-tenancy. So I think the one more highlight that I want to say, this is the development that we are doing for Cinder and Manila. We have drivers where we have implemented the Cinder and Manila APIs. These drivers are going to be available as part of our product as it becomes GA later this year. We are working on upstreaming these APIs and the driver up into OpenStack. So we're working on that. This is a snapshot of what we support today in terms of APIs that we've implemented. We're working on more, right? So the Manila driver that we have created, that's inherently going to be multi-tenant using the containers. So that's really what the demo was about. I'm going to hand it over back to Abhijit for the rest of the presentation.
Thanks, Sachin. So we understood the multi-tenant part. So again, as I said before, this is part of an upcoming product we are launching later this summer. It's called Veritas InfoScale Access. It's a software-defined NAS for unstructured data. The way it works is it supports commodity SAN, DAS, runs on pure commodity storage. It's a software-defined storage. It runs with a policy-based provisioning for provisioning your storage over any SAN or any commodity storage. It seamlessly integrates into public cloud. This is a cloud gateway we have written, which goes into public cloud from your on-premise or private cloud. And it does any protocol access, NFS, SMB, S3. And finally, of course, as we just saw, it provides a file and block-based storage for OpenStack-based private cloud. It's coming up. And it's, of course, resiliency, performance, storage, all the Veritas storage qualities are part of this product as well. With that, that's the end of this presentation. However, we have 3 more presentations tomorrow on Veritas products in OpenStack ecosystem tomorrow in the same room. So please stop by. And again, please stop by our booth at C29 in the marketplace. We are there to explain both the products that we have in Veritas around OpenStack, Veritas OpenFlame, and Veritas InfoScale Access. Thank you.